what we are discussing about in last class, right? We have seen the concept of the DHCP protocol. Okay, so DHCP have a DORA operations, right? So discover, offer, and request and acknowledgement we have. So initially what happened if the PC doesn't have any IP, so it will use the source IP as a 0 or 0 or 0 or 0. And destination IP will be 255.255.255.255. So this is a very important interview question, right? They will ask you what will be the source IP and destination IP in the IP header. And they will also ask you what will be the source MAC address and destination MAC address, and what will be the source port number and destination port. So source port number will always be 60 because 60 is used by the client and 67 is used by the server side, right? So yesterday we have seen the concept of the RARP protocol as well. If you guys remember that in a RARP,
Yes, sir.
we have seen that in the 1984 this protocol was key, right? The problem with the RARP is just the opposite of the ARP protocol. So in the ARP, what happened? We get the MAC address information. If you don't have in a RARP, it's just a reverse of that one. So in this case, what happened? We get the IP information. So the problem with the RARP protocol is what it only allow you, right? Not only allow, it works on the data link layer concept, right? So it means that for each broadcast domain, you must have one RARP server. So to avoid this problem, we came with the solution called the BootP protocol, right? BootP was awesome. It was came in the 1985, but the BootP has a own issue, like you have an issue with the timer and those concepts. So then after that, we have came with the concept is called DHCP protocols. But again, DHCP is still using the feature of the BootP protocol. So DHCP came in the 1993. So this is how the journey was started of dynamic IP, right? Dynamic IP 1984, 1985, 1993. In a DHCP, we have seen that the two behavior, like, for example, if you just have a LAN communication and if you allocate the dynamically IP address to the LAN guy, so you can use this configuration, right? You don't need to define the default gateway. But if you have a WAN DHCP, then you can go with the default router. That's will be the default gateway for the PC and the DNS server. So if you want to, this will be the primary DNS server. And if you put the another one, put the 7.7.7.7, this will be the secondary DNS server automatically. So for example, if your primary is not working fine, automatically it will switch to the secondary one. Then we have seen the concept of the relay agent. Relay agent comes in the picture, right? When the server is not present in your own broadcast domain. For example, when your server is not present in your broadcast domain, right? Then relay comes in the picture. So the major goal of the relay agent is what? It's simply going to convert your broadcast packet into the unicast, because normally what happened, this is my router over there, right? This router have this interface 0/0, this router have this interface 0/1. Take example, if you have a LAN on this guy, okay? So if this guy is going to generate the broadcast packet, take example, and you have a DHCP server, take example, this is router number 2, we have 0/0 again, and the DHCP server is located over there. Take example over there, right? So understand this concept. We have a one broadcast domain over here, right? And we have another broadcast domain over here. So normally when the PC is going to send the Discover packet, this Discover packet is normally a broadcast packet, right? So this broadcast packet cannot go beyond this interface, right? That's a meaning of router. Router break the broadcast domain. So in that case, we need to use the concept of the relay agent. So basically what relay agent is going to do that, it's going to convert this broadcast packet into the unicast. And when this guy is going to do this thing, right? When the router is going to convert this broadcast packet into the unicast, what happened? Now this router is behave like a server. So when this router is going to behave like a server, what happened? Your source port number also will be 67 and destination port number also will be 67. So that's a very, very important stuff. So when your router will become a server, it's going to change the port number. Previously, when the PC is going to send the Discover packet, in this Discover packet, what happened? You have a source port number 68 and the 67 is the destination one, right? But when the router is going to convert this Discover packet, right? What happened? Same Discover packet, but the port number will be changed over here. All good? Now, take example, we have this one of the router we have. That's a server, my DHCP server. And then after that, we have a switch in between. And this switch is going to provide the connectivity between the router to the PC, right? So it's like an interface we have. a guy, a media, right? And we have another PC2 now, and we have PC3 now, right? So three PCs we have: PC1, PC2, and PC3. PC1, I can call this guy 1, 2, and 3. So right now they don't have any IP addresses allocated over there. So I'll make sure that this interface we have a 0/0, 0/1. I'll make it this guy. And this guy has a 0/2, and this guy has a 0/3 right now. Okay, and this interface we have a 0/0. At the same time, this is my legitimate server, I can call it. Right? Legitimate service means what? This is a genuine server. From that server, I can get the IP address, right? So this server has a pool. So if you see that the pool of this guy is what? IP DHCP pool. And the pool name is ABC, I can call it. I said the network will be what? It should be the network will be 192.168.1.0/24, right? And if you want to give the default router, you can give the default router as well, right? That's will be the IP address of the interface. I said the 1.100. This is the interface we have. The IP address of this guy will be 1.100. Same way, what happened? Right now, everything is working fine. So whenever this PC will request the IP address, so he will make a request, hey, I need IP address. So he will make a broadcast. He will send the Discord packet, and then what happened? Out of one will send the offer packet to this guy. Same way, when the PC2 will require the IP address, he will boot up and he will send the request to this guy, hey, I need the IP address. He will get the IP address to this guy. Same way, this guy as well. So right now, every PC will get the IP address from the legitimate server, right? Every PC will get the IP address from the legitimate. So he will get the IP address maybe 191.168.101. He will get the 102 and he will get the 103. There's no issue. But what happened? We know, right? In this world, we have a combination of people, right? We have a bad guy and the good boy as well. So this is the good boy. At the same time, what happened? In this picture, we have a bad boy as well. So this is the bad boy. And the major goal of this bad boy is what? The major goal of this bad boy is just gonna make an attack in your network. In what scenario you would use router as a DHCP server in the production? Not in any case, man. If you don't have a real server, like a Windows server, if you don't have, then you can use the router as a DHCP server. In CCI lab exam perspective, if I talk about the Cisco exam perspective, in a Cisco exam, what happened? You will always get a router as a DHCP server, CCI exam. But in the production network, rarely you will see as a router as a DHCP server. You will see as a what we call normal the Windows server as a DHCP server. But take example, if you have a very low budget, and if you do if you have a 10 to 20 users, and if you don't want to buy the real server for the DHCP, then you can make a router as a DHCP server as well. Not a big deal. So your router can do the routing as well as, understand this concept. Your router can do the routing as well as, and your router can do the DHCP services as well as. Understood, Bujar?
Yes. Thank you.
Most welcome. So now we have a bad guy. So this is the legitimate order, and this is the bad guy. And I can call this bad guy is what? It's the attacker, right? So the bad guy has a connectivity with the switch now. And this bad guy also has a pool. So he said that, hey, you know one thing, I also have a pool for you. So my pool is what? I can call this guy as a CCNA. Let's have a look. And 2.0/24. And default router, guys, please pay attention. The topic is very important. And in this guy said the 2.100. That's a default gateway. So this interface we have, I can call this interface as the IP address is 2.100. Right? So now understand what happened. Try to understand this bad guy also have a DHCP pool configured, right? And this legitimate server also have a DHCP pool configured. Okay. All done. Understand the concept. Do you have any kind of authentication in the DORA process that we have seen the discovered, offer, and request technology? Do we have any kind of authentication field? Like we have seen that, right? If you guys remember that in the BTP packet, we put the command BTP password to just secure the BTP information, right?
Yes, sir.
Do we have anything in the DORA? And even in the ARP also, we don't have any concept of the authentication. Remember, in the ARP also, we don't have any concept of the authentication. So in the DORA, we don't have any kind of authentication field. I cannot say that, this PC cannot say that I only need an IP address from this guy. He cannot say that because he doesn't have an ability, right? So normally understand this concept when this guy is gonna turn on the PC, right? So this PC is right now on. So what happened? He will request the broadcast packet. So he will generate the discover packet, and obviously, right, my discover packet is a broadcast packet. So take example, the MAC address is E, so I'll put the MAC address E over there, and the system will be 250, sorry, FFFF, right? That's a layer 2 MAC address for the broadcasting, right? So when this broadcast packet comes to the switch on this particular interface, the behavior of the switch is what? It's going to learn the source MAC address, right? The switch is going to learn the source MAC address on the 0/1A. Then it will look up the destination MAC FFF. And based on the destination MAC, what he will do that? He will forward the packet to this guy. He will forward the packet to this guy. And he will forward the packet to this guy as well. And he will forward the packet to this guy as well. Understand the concept. You have a port number as, I'm so sorry. You have a port number as well. So I'm not going to write the, okay, let's write the IP part. So IP will be 0.0.0.0.0 and destination will be 255.255.255. And I have a port number as well. The port number will be what? We have a 68 will be source and 67 will be destination part. Understand this 67 is not enabled on the PC side. The 67 is not enabled in the PC side. Okay, it doesn't mean that you cannot enable it. You can, if you have ability, there's a lots of tools in the market right now. You can do that. Okay, you can make a PC as a server as well. So you can enable it, but default behavior, it's not enable it. So what happened? This PC2 and PC3 will drop the packet because I don't have a 67 enabled. 67 is enabled on this guy and 67 is enabled on this guy. So the bad guy also received the discover packet and the legitimate server also received the discover packet because it was a broadcast packet, right? What happened in this case now? Take example. Take an example. If the bad guy has sent the offer packet, then if the bad guy has sent the offer packet, then if the bad guy says, hey, let me send the offer packet to you, right? On the 0/3 port number, I have sent the offer packet. And this offer packet is received by the PC now. So in this case, what happened? This PC will get the IP address from whom? This PC will get the IP address from the 192.160.2.1 and default gateway will be what? 192.60.2.100 will be default gateway. Understood? So this is the IP information. This is the default gateway information. Same way. If this PC will make a request, right? If this PC will make a request, hey, I need a IP address. So now the switch will receive this packet. Again, it will do the broadcast packet. It will send this broadcast packet to this guy, and this guy, and this guy, right? So what happened? Of course, they will drop the packet. They will drop the packet. So I'm dropping the packet from this side because they don't have a port number enabled. So now the router 1 is giving the reply to this guy, and he will receive the IP from the genuine server 1.1, and the default gateway set will be the 191.1.100. Same way, the PC also make a request. He will get the reply from the legitimate server. Understand the concept right now. Okay, he will get the IP address from the legitimate server, genuine server 1.3, right? This is the 1.2, and the default gateway will be the same, like a. Okay, now there is no issue, right? There is no issue between the PC and PC2 and PC3. There's no issue. So if the PC2 understand the concept, right? If the PC2 now is gonna send the any traffic towards the internet, if the PC2 and PC3 is gonna send the any traffic to the internet, how will they send it? They will send the packet to the default gateway, and the default gateway will route the packet to the internet. Same thing, the PC3 will send any packet to the internet. They will send the packet to the default gateway, and they will route to the internet over there. No issue. But understand the concept. If the PC1 is gonna send the packet to the internet, how they will do that? Bad guy has also connected with the internet. So he will send the request, he will send the packet to whom? He will send the packet to this bad person because of the default gateway. Because of the default gateway, he will send the packet to whom? The bad guy. And now the bad guy will do what? He will send the packet to whom? ISP. Now you have a question. Hey, Law, there's nothing bad in this one. Because I'm just forwarding the packet to the bad guy and bad guy is sending the packet to the ISP. Again, understand the concept. What this bad guy can do that? Either, right? Either they can drop the packet, right? Either they can drop the packet, or what he can do that, he will just forward the packet, right? He will just forward the packet, but before forwarding it, what he will do that, he will just copy all the information. Copy all the information means what? Whatever the data that you are sending to the ISP. For example, if you are doing the bank transaction, and if you're sending the some confidential information to the different person, or maybe you're sending the some your bank account number, or maybe the OTP, right? If you're sending the OTP information to the maybe the some servers, right? Then what happened? All this OTP is handled by this bad guy. It's like a man in middle attack. It's like a man in middle attack. This bad guy can do anything. Either they can drop the packet, either they can forward the packet, and you have no idea, dude. I'm telling. Okay, let me tell you one thing. Have you ever seen, right, whenever you're turning your laptop, have you ever checked what IP address do you have in your laptop? You never check that. You're just browsing the internet. If you're sitting in the cafe, if you're sitting in the college, if you're sitting in the company, if you're sitting in the park, anywhere, if you're sitting in your family house, like a cousin's home, right? Never you check the IP address. You just start doing your work, and that's a like problem, right? And that in that case, what happened? Bad guy comes in the picture. If this guy will give the IP address to this PC, everything will be compromised now. Everything. He's like a eavesdropping, right? He's like a eavesdropping. So whatever the traffic you're sending to the ISP, all the traffic will go by the bad. It's like a man-in-middle attack. So to avoid this problem, right? To avoid this problem, what we have came with the concept. See, this two guy has no issue because he's getting the IP address from the legitimate server. But unfortunately, what happened when this PC has requested for the IP address, he got the IP address from the bad guy. So to avoid this problem, right, what I can do that I have to introduce the DHCP snooping feature that you're going to do on the layer 2 side. It means that you're going to do on the switch side. So you have to enable the DHCP snooping feature. What this feature is going to do that simply, this feature is only going to accept the offer packet. He's going to only accept the offer packet from the trusted port. So the main agenda, if I'm going to summarize the DHCP snooping in the just two line, right? The DHCP snooping is just going to accept the offer packet, right? Because he's also sending the offer packet and he's also sending the offer packet. So with the help of DHCP snooping, what I can do that, I'm just going to make sure that I'm going to inform the switch, hey, listen to me. You're only going to accept the offer packet from the trusted port. So I will make sure that this interface should be the trusted port for the DHCP snooping. So when I'm going to make this guy interface as a trusted port, I will only accept the offer packet from this interface, not from this interface. So automatically the packet will be filtered out. Or we can simply call as a reply packet. Remember yesterday we have seen the request and reply packet. So request will go by the PC and reply will come by the server side. So reply packet I can only get from the trusted port, not from the untrusted port. So by default, all the ports, right? By default, all your switch ports are untrusted port. All the ports are untrusted. So I will just make sure that this interface where the DHCP server is configured, I will make sure that this interface will be the trusted. I will get the IP from this port only. So let me show you the first, what we call attack. Then I'll go with the configuration of the DHCP snooping. Okay, we have a DHCP snooping now. So, okay, DHCP snooping, and we have a diagram. So understand this concept. I have a, let me turn on these devices. And I have a DHCP server. Take this one in the downside. I'm so sorry. Remove this guy. So again, this is my legitimate server. This is the bad guy, right? And let me, and this is the switch. We have these are the users. We want user one and user two we have, right? So normally this interface, I'm going to configure the pool right now. I'll just show you the configuration right now, then we'll see that. Okay. Let me take the router one, the router two, switch one, router four, router five. We have. Let's go to the pin now. So simply what I can do that, I'll just do the configuration of the DHCP snooping. So on the router number one, what we can do that simply Ethernet interface 0/0. IP address will be 1.100. That will be the interface IP. And here we go. And then I said that I'm not going to enable the debug command. We have already seen the debug in the last class, right? IP DHCP pool we have ABC. I'll make this guy's okay, that's fine. ABC network 1.0/24. Default router, you can set it if you want. It's 1.100 exit. On the router number two, same thing, we need to do that because router two also have a one DHCP pool because the attacker can also create the one DHCP pool, right? So we have a 2.100. This guy should be 2.0 and this guy will be 2.100 now again. All done. So let's do the configuration. So let me paste this configuration on the router number one first of all. I'll do that over here. All done. So this is for the interface configuration, and this is for DHCP pool configuration. Let me take the different color. And the same thing on the router number two right now. Make sure that the font should be little zero. So little decrease, right? So I don't have a space right now. So again, this is the black color for the interface configuration. So we have two different pool, right? So let's copy and paste it. So for router one, no and go. Host name will be router one. And come on. Done. And how about the router number two now? Router two, we have this guy and no and no. Come on. Yes, and done. So host name will be router number two right now. Come on. And here we go. So I'm done. So let me turn on the switches as well. Right. So my switches is down right now. I need to know and yes. So switches is also up. And now I just need to go on the router four. That's my user. So router four is my user number one. You can see that this is the router four is my user number one. Come on. Let me turn on the, okay, it's get up now. So if you see host name as the router one, so user one, I can call it. So hyperlink not right? And interface is 0/0. I say the IP address DHCP and no shutdown. Let's have a look from where I'm getting the IP address. So normally when this guy is gonna make a request, right? He will send a Discord packet. Discord packet comes to over here as well over here, right? So he will drop the packet because of the port number. Now let's see who will accept the packet. Can you see that from where I'm getting the IP address? I'm getting the IP address from the 2.2 from this block, from the bad guy. Let's like an example of the router 5. That's my user number 2 right now. Let's see from where. So this is the, now this user get attacked. Host name is user number 2 and interface is 0/0. No shut. Come on. No shut. IP address DHCP. Give me 1 minute. Okay, guys. Why I'm not getting the IP address? Is everything is good on the router 5? I see our host name user 2, 80/0, IP address DHCP, no shutdown. Yeah, it's cool. Perfect. Shut, no shut. Okay. No IP address DHCP. IP address DHCP. What happened to you, man? Switch one. Do we have this port is down right now? So interface brief. So IP address brief. It's up. Sorry. It's up 0/2. Let me define the IP address manually on this interface. IP address 101. Let's ping it. 100. Hold on, the spanning tree protocol is going on, man. 30 seconds. So use the spanning tree. So spanning tree. It's a coding state. I am not able to ping. So there is some issue on the router 5, guys. Some hardware issue on this one. Let me check my interface is up or not. Do so IP interface brief. My interface is also up. So there's some issue on the router 5. Let me restart this guy. I'll just go to the device and let me power on, power off, and let's power on. Let me wipe this configuration they have. Okay, so let's try on the router 4 again. And what I can do that. So right now I got the IP address from the user number bad guy. Let's shut down and no shut down. Let me shut down this PC again and let's no shut down. Let's see from where I'm getting the IP address now. So no shutdown. So always right, whenever you're gonna turn off your PC and turn on the PC, every time you will get a different IP address, right? So this IP address is only valid for the 24 hours, right? This IP address is only valid for the 24 hours. That's called as the lease time. So this normally this lease time comes in the offer packet. So you can see that now I'm getting the IP address from whom? I'm getting the IP address from the 1.2. So now my user is not getting attacked. So I'm getting the IP address from the legitimate server. So previously what happened? My user got the IP address from the 2.2, which is the attacker side. Now I'm getting the IP address from the 1.2, which is my legitimate server. Let me shut down and no shut down again. Have a look. And no shutdown. Meantime, let's go to this guy and let's turn on this guy. So let's see. Now I got the IP address from the 2.3. So sometimes I'm getting the IP address from the bad guy. Sometimes I'm getting the IP address from the legitimate server. So if you're getting the IP address from the legitimate server, that's fine. That's okay. But if you're getting the IP address from the bad guy, they can do the man-in-middle attack to you, right? So to avoid this problem, we need to go with the DHCP snooping. Let me do that for this one as well one more time. So maybe otherwise I need to change this router. So interface 0/0, no shutdown, IP address DHCP. Okay, this is some issue on this router 5, guys. Even we can configure the IP address manually, but it's not working right now. IP address 101. So even can I configure the manually, I'm not able to ping 100. I don't know why. So there's some hardware issue on this guy. Leave it. So let's avoid this problem, right? I don't want to get the IP address from the 2.3 from the bad guy. We need to enable the DHCP snooping. So DHCP snooping, as I mentioned, that you are only going to enable on the switch side. DHCP snooping feature, you're only going to enable on the switch side, on the layer 2 switch or layer 3 switch as well. Right? But make sure that your switches support the DHCP snooping. It's not like that every platform does support the DHCP snooping feature. You need to check your data set, right? Cisco data set. Don't worry about that, how to check the data set and those things. Definitely we'll discuss this thing, like how to check the data sets, like which feature is this switch is going to support and which feature the switch is not going to support, which version they will support. I'll help you that in the last day of the class. Okay, so make sure that whenever this things comes in your mind, right, whenever you're working for the production network and these things comes in your mind, okay, which protocol and which feature is going to support by this switches, you are always going to check the data set for that one. So you need to enable the DHCP snooping, and after that, first you need to enable the DHCP snooping globally, and then you need to enable the DHCP snooping for the VLAN, because on the switch we have a multiple VLANs. Maybe this guy is a VLAN number 10 and this guy is a VLAN number 20, and you need to make sure that I'm only going to enable the DHCP snooping for the VLAN number 10. So what you need to mention over the VLAN number 10. So right now I don't have any VLAN number 10 and 20. I just have a VLAN number 1. And after that, what happened? First, you need to enable the globally. Second is the VLAN. And third thing, you need to make the interface as a trust port, because by default, all the interface are untrusted. So just go to the switch one diagram now. And let me go to this router 4. Let me shut down this interface so that I will not have any IP addresses. All done. So if you see, I don't have any IP address on this particular interface. Right? I don't have anything. So now if you see what I can do, that I'll just need to go, I say that IP DHCP snooping. The first command that's going to enable the DHCP snooping for the globally. Second command, you need to make sure that this snooping is only going to enable for the VLAN number 1. And the third command is what by default, all the ports are untrusted. If you see the show IP DHCP snooping now, you can see that I don't have any trusted port over there, right? I have a DHCP snooping for the VLAN number 1, right? But I don't have any trusted port over there. So what I can do that, I just need to enable that. I'll make sure that this should be the trusted port, right? This should be the trusted port. By default, all the ports are untrusted. So this will be untrusted, this will be untrusted, and this will be untrusted. So this port will be trusted. So from the trust port, right, we will get the reply packet. So take example, what happened if this guy, right? If this guy will send a Discord packet, now when this guy will send the Discord packet to this guy and this guy, so when he's trying to send the offer packet, when he's trying to send the offer packet, what happened? The switch is saying, hey, you are sending the offer packet on the untrusted port, I will not gonna accept it. But when this guy is gonna send the offer packet, he's a trusted port, he will accept and he will forward the packet to the user number one. So normally what happened now, the user will get the always IP address from the legitimate server, not from the attacker one. So let's go on the switch one and let's enable the ports as a trusted, which interface is 0/0, which is my this interface 0/0. I said the IP DHCP is no ping trust. So now if you put the same command, do show IP DHCP is no ping, you can see that my this interface is a trusted port. So DHCP snooping is for enable for the VLAN number one. Now, if you see, if you go to the router 4 and if you put the command no shutdown, I must receive the IP address, right? I already have this configuration. You can see that on the interface 0/0. On this particular user number one, I already have an IP address DHCP. My interface is also up right now. You can see that. But I'm not getting the IP address. The reason is that you're not getting the IP address because when you're going to configure the DHCP snooping, try to understand the concept. When you're going to enable the DHCP snooping on the switch side, when you're going to enable the DHCP snooping on the switch side, two things will be enabled in a background. Two things will be enabled in the background. What two things? The first thing, right? Option number 82 will be enabled. Option number 82 will be enabled. Right? These are the just a magic cookies, we can call it, that we have seen the yesterday options fly, right? Some option we have seen it. These are the just a magic cookies. And second thing, what happened when you enable the DHCP snooping, once this services will be enabled, automatically what happened? This switches is behave like a now relay agent. Understood? So the first option 82 will be enabled. Second thing is what? Relay agent comes in the picture. So now when the relay agent comes in the picture, or we can say that when this switches is now behave like a server, DHCP server, right? Then what happened when this guy send a broadcast packet to the switch one is not processing the broadcast packet to the router number one. We need to give the IP helper address command yesterday that we have did. But on which interface? Should I give the IP helper address command on this particular interface? No, we cannot give it because it's a layer 2 interface. Can I give this command on this particular interface? No, we cannot give it. This is the layer 2 interface, or maybe the trunk interface in future as well, right? So what we have to do, we need to create the SBI. Remember, SBI is what? Switch virtual interface is a logical interface for the layer 3. So you just need to go on the switch one and what you have to do that, let me copy this configuration in the notepad. The switch one, you need to configure IP DHCP snooping. IP DHCP snooping for the VLAN number one. And I say that interface is 0/0, IP DHCP snooping trust, right? And then I can say that interface VLAN number one, because it's now behave like a relay agent. I said the IP address will be what? I'll give the any IP address. Maybe this guy's say that 1.10/24, because we cannot give the IP address on the layer 2 interface, right? So I need to create the layer 3 interface on the switch side. So we need to create the SVI, switch virtual interface. And then I can say the no shutdown. And here I can define the IP helper address. And I said in the IP helper address, I need to define the IP address of the router, this DHCP server. That's done. All done. Now, if you go to the router 4, wait for some time, you will get the IP. Make a refresh. Let's make a shutdown. And then we'll see the no shutdown. All good? I got the IP address. So now every time whenever you're gonna turn on the PC, right, you will always get the IP address from the legitimate. So if I'm gonna make again no shutdown, right? Always you will get the IP address from the legitimate server from the 1.0 subnet and no shutdown. You will not never get the IP address from the R2, or we can say the bad guy. See? Again, no shutdown. All done. So you will never get the IP address from the bad guy. So the one way what you can do that, you need to go on the switch one and you need to define the IP helper address, interface VLAN number, you need to get the SBI, and you need to define the IP helper address. Understand the concept over there, guys. It's very important. So even when you define the IP helper address, then what happened in this case also, right? So this will be the scenario-based question that you are getting in the interview. So when this guy is gonna send the Discord packet, right? So in the Discord packet, again, what happened? It was a broadcast packet. The port number was 68 to 67, right? But when he's gonna send the Discord packet to the router one, so already I have a IP helper address command. So this guy will convert this packet in the unicast. So when this guy is going to convert in the unicast, at the same time, this guy is behave like a DHCP server, or we can call it a relay agent, right? So the port number will change from the 67 to the 67. Okay. One way that you can create this way, right? You need to create the IP helper address on the switch side. If you don't want to do the IP helper address on the switch side, then what you can do that alternative. Disable option 82. Simply. So for example, let's go to the switch one as that in no interface VLAN number one. Let's delete this SBI. So I don't have interface VLAN number one. Do show IP interface brief if you see. Show IP interface brief. I don't have this interface. Interface VLAN number one. So now if you go to the router 4 and shut down this guy, right? And make a no shutdown. So now you will never receive the IP address because SBI is not there. So this guy sent the broadcast packet to the switch. Switch is not able to determine where should I forward this broadcast packet, because after enabling the DHCP snooping, this guy's behave like a server now. So what you can do that on the switch one, you can simply, if you say do show IP DHCP snooping, my option 82 is enabled. You can simply disable the no IP DHCP snooping. Come on. Disable now. So now you can see that I must receive the IP address. Shut down and no shutdown. So I don't need to create the any SBI over there. So now you got the IP address 1.4. So always you will get the IP address from the router one side. So after disabling, so if you disable, not after, if you disable the option 82, then no need to create SBI. Now, question is that which one should I prefer? Should I go with the this one IP helper address, or should I go with this one? So the first one I'll tell you, it is if you are a service provider, right? And if the service provider is giving the, DHCP is not like that you're only gonna use in the LAN in network, right? Only for the user perspective. Service provider always giving the IP address, maximum time is giving the IP address to the DHCP. So the Boozer has just asked me the question, what happened in in a product scenario, should I configure like a DHCP server or not? So see the scenario right now. So the service provider, right? The service provider router we have allocated over there. So this router is behave like a DHCP server. This router is going to allocate the IP address to this interface. This is a customer network, right? The customer router. This router will allocate the DHCP IP to this interface. So in that case, you can go with the DHCP server as a router. You're not going to install over the separate server just for the one customer. So take example, when you give the IP address to this guy, right? So you need an option number 82 over there, because option number 82 is giving the client information. Option number 82 is giving the client information. So it is a security perspective. You need to enable the option number 82. Okay. But if you are using in the LAN environment, right? If you're in the LAN environment, if you have, then you can disable this guy. That's not a big deal. So it's depend on the scenario. So if you have a scenario towards the ISP side, and if you want to make a security in your network, go with this guy. If you want to lose the security, go with this guy. But again, in a production, you will see anything, right? Because most of the time in the production network, what happened? People are copy the configuration from the website, right? So normally they do just copy and paste the configuration, because eventually they need a ping, that's all. But when you go at the high level things, right, architect level, you need to think about both the perspective over there. Guys, questions?
So just obviously just want to, would you please remind again about option number 82?
Yeah, option number 82 is just by default, this feature is enabled, option 82. When you're going to enable the DHCP snooping, this option 82 is going to it's going to contain the information about the client interface, this interface, and switch, I mean, the switches interface where the client is connected over there. So this is the helpful when the service provider is offering the IP address to the multiple customers, so that they can get the idea from which interface I'm getting the request for the packet, the Discord packet. So in that case, you need to enable the option number 82. Anyways, by default, it's enable it. So it's never recommendation to disable over there in the service provider environment. But if
So
you're,
we have to,
yeah, go ahead.
okay, I'm sorry. So we have to enable on every switch interface.
No,
where it's
no, no.
connected to the
If you're gonna enable the DHCP snooping, automatically this will be enabled.
Okay, so DHCP snooping is already excuse me, is already on the switch, right?
Yeah,
It's already
not
disabled.
already on the switch. I have enabled manually DHCP snooping.
No, I mean, okay, but it's disabled basically,
By
but you
default,
have to
it's
enable it.
disabled. By default, it's disabled. By default, the DHCP snooping feature is disabled. You need to enable just for the security perspective, so that any attacker cannot do the attack in your network.
Right. Okay. I see what you mean. Okay. And and again, what I was saying that, so on this specific topology, so you have the router on the left hand side. So isn't it?
Yeah, this one, right?
You
This
have
one.
been, yeah, as a bad guy. We just name it as a
Okay,
bad guy,
the bad
right?
guy. Okay, the attacker.
Yeah.
Yeah.
Yeah, attacker basically. Yeah. So to avoid attack from this specific side router, so we just enable the DHCP snooping, right?
Exactly right. So I make sure that this user, whenever this user will make a request for the IP address, I should not get the IP address from the bad guy. That's why we need to enable the DHCP snooping.
Okay, so but generally the rest of the routers or rest of the user connected to the so they have automatically dynamic DHCP already configured, but this one because it's configured as a static, is that the reason we need for the DHCP snooping?
And I missed your last point. You said that key. Okay, you are saying that key only for the dynamic one. DHCP snooping, yes, only for the dynamic one. Of course, if you're gonna take example, if you have a user over there, another user, and I give this guy's IP address manually over there, 191.168.1.4, then there's no need
Right.
to configure the DHCP snooping, right? Because I have a manual configuration. See, snooping only comes
Okay,
in the
I
picture
see.
when we have a DHCP. See the name. When you have a DHCP, then snooping. If you do the static
So
configuration, there's no need to DHCP over there, right?
okay, so for static you don't need that, but why specifically on this topology? I mean, we are afraid that this attacker might destroy the network.
Because attacker can enter in your LAN network, right? If they enter in your LAN network, they can do the man-in-the-middle attack in your network, right?
Okay, I see. So this bad guy, he's on our LAN side.
Yeah, he's in the network right now. He brings you know laptop over there, and they are now we have like a DHCP server over there.
Okay.
So now he can allocate the IP address. Now he can allocate the IP address to the user, right?
Uh-huh.
And if
Yeah.
if the IP the router 4 and router 5 will get the IP address from the attacker side, then what happened? Whenever he will send the traffic to the internet, all the traffic will go by the attacker side.
No, that's fine. I understood that. What I'm saying there is that so if he enters into the network, okay, so obviously obviously to stop his attack, so we have enabled the DHCP snooping,
Right,
isn't it?
right.
Yeah. But so what about if somebody else come from any other side? So how will you protect that?
Or any other side in the sense of what?
I mean, there are multiple users, isn't it, on the network? Like you have a user 1, user 2.
This DHCP snooping is only preventing the DHCP attack, not other attack. Okay, you're getting my point. DHCP snooping is only
No,
preventing.
yes, I understand. I got this point already. That has already clarified the confusion. But I'm saying that we have to avoid the attack from the bad guy, right? We have disabled the DHCP snooping. That is fine. That's understood. So what I'm saying, let's say if somebody else wants to attack the network, let's say user 2, for example, or any other. So how can we avoid that at the same time? We understood on that specific interface, we enabled the DHCP snooping, or the DHCP snooping is configured in a switch. That is fine. We'll block him. That's fine. But if imagine somebody else, or maybe user 1 or user 2, if they try to attack into the networks, so they will be blocked.
Which attack? I'm asking.
I mean, obviously, try to hack the information or
So it's not a DHCP attack, right?
It will be a DHCP attack, yes.
So if it is a DHCP attack, I have enabled the DHCP snooping. So I'll make sure this interface only at the trust port from the legitimate server. So where is my legitimate server? Only that port I'm going to make this guy the trusted port, right? So of course, if this will be the untrusted port, right? So I will never receive.
So I see. Okay. So one port will be trusted, rest will be untrusted.
Of course. Now you understood?
I see.
No,
got
you
it.
join in the mid?
No. I did not join the mid. I mean, I joined in the mid. Obviously, I didn't want to disturb you.
No,
so
that's
that's how.
fine. Okay, so next question, what is the DHCP snooping? Do block ports or ask the identification from the who? Yes, ask the identification of the who, not, so no, block port or ask it. It's not gonna blocking the any port over there, DHCP snooping. It's not gonna asking for the identification. So there is no, if I'm gonna make this guy the trusted port, he's not gonna ask the identification, hey, who the hell are you? He's not gonna ask that. He's just gonna make sure that if I'm receiving the offer packet, I'm only gonna allow the offer packet from the trusted port. He's also sending the offer packet and he's also sending the offer packet. So I'm only gonna allow the offer packet from the trusted port, and he will send the offer packet to this guy. Understood? Port security, maybe what is the port security? Port security is a different thing. I read before snooping and spoofing. What is the meaning of that? Snooping and spoofing, both are two different things. Spoofing is what? For example, this is my Netflix account, right? That's my Netflix account is law, and this is the password I have. For example, this is a user ID, and the password is what? 123. So this is my Netflix account. This Netflix account is used by the Puneet as well. This Netflix account is used by the Amit as well. This Netflix account is used by the maybe the Moshin as well. So my Netflix account can be used by some other person as well. Spoofing means what? When somebody is gonna use your name. When somebody is gonna use your name without informing you. For example, already I have a IP address is 1.1.1.1.1, right? Some other person, what happened? They will spoof this IP address 1.1.1 and may perform the attack in your network 1.1.3. So that's called the IP spoofing. So already 1.1.3 is in my network. So what happened? This PC got assigned itself as a 1.1.1 and he will make an attack in your network. So what 1.1.3 get to know that, hey, I'm getting the message from the 1.1.1 and 1.1.1. I know the 1.1.1 because he thinks that I'm getting the message from this guy. He thinks that I'm getting the message from this guy, but eventually what happened? The message coming from this user. That's called as a IP spoofing. So spoofing can be done on the layer 2 side, layer 3 side, and the layer 4 side as well. Snooping is
So,
a yes.
in general terms, if somebody try to hack your information or just want to get into your, I mean, now just to make us understand, you explained in a simple language. If somebody wants to use your name, etc. So if it's if somebody asking in an interview, what is the DHCP snooping? How would you actually explain it? In the same way or what?
Okay, no, can you explain the law? Can you explain last question? What I missed that.
I think my line is not very clear today, probably. So what I was saying, in general terminology, if somebody asks me what is how do you define the DHCP snooping?
Okay, you are asking for the definition of the DHCP snooping?
Yeah. Okay, let's say definition. Yeah.
Okay. So DHCP snooping is the feature of the DHCP that helped me to prevent the attack from that helped me to get the IP address from the legitimate server, not from the other server. So DHCP snooping allow you to make the one port as a trusted port, and from the trusted port I can only accept the offer packet, or we can say the reply packet simply. Okay, and DHCP snooping is by default disabled. You can enable on the per VLAN basis, and you can make the interface as a trusted port. So once you enable the DHCP snooping, then what happened? Automatically two features will be enabled. One is the option 82 and another is the release end. So after that, what happened? If you're gonna get the IP address on the router side or user side, then you need to configure the helper address on the switch side. And once you configure this thing, then what happened? You configure, packet flow will be changed. So whenever the user will send the packet to the Discord packet, it comes to the switch one, and switch one will convert those that Discord packet into the unicast. So you can explain it that way.
No worries.
Bad guy, which
Thank you
interface
so much.
and how attack I have a 3 interface only, which is configure R1, R5, R1 switches. So bad guy is this interface, man. Sakil, this interface is the bad guy. This last one.
There's a good boy, bad boy.
Yeah, it's a good boy.
Simple
My
language.
question is
Simple
how we
language.
attack because we're not configured in the switch side, the bad guy interface.
I have a, this is just a name I did give it, nothing else.
Yeah, it's just a name to
It's just a
understand.
name. I never define on the interface is the bad guy over there. It's just a name over there.
Yeah,
If you want to define, if you
basic.
want to give the description of that one, you can give it them. Like this way. For example, interface 0/1. I can give the description. Hey, there's a bad guy is connected.
There is a trusted network and there's an untrusted network. Simple language.
Simple.
Good boy is a trusted one. Bad is never be trusted. That's it.
That's it.
Untrusted, sorry.
So in
This is
this way, you
the
can
Cisco
define it.
switches you are configuring, but how we find these other switches?
Sorry, can you repeat the question? How you?
This you telling about this Cisco switch, right?
Okay.
So how to find these other switches? This
You mean so if you have a Juniper in that between Juniper or maybe the HP
Linksys.
Apart from the Cisco, right?
Yeah.
So in the third file also we have a configuration of the DHCP snooping. It's not like a Cisco providing features. You have this feature on the every vendor. Only the configuration is change. The technology is same, configuration will change. Can legitimate someone know about the router? If they want, they can do that. We have multiple tools, but normally they cannot identify it. Always remember one thing, Kairaz, remember always one thing, you are the network engineer. Router cannot identify anything. Router is just a router, non-living thing. You are the network engineer. You do have ability, you can identify it. Okay, that I'm getting the IP address from the bad guy or not. So this is the work from the NOC side, right? NOC engineer, that's always do the operation. So normally router cannot do anything. All you do, network engineer. Any other questions? Okay, if not, then I have one more interesting concept for you guys. Okay, so take example, this is my service provider. And this is the customer we have. So service provider, so on a service provider, what happened? You will always get the IP from the service provider. So this is a customer network and this is the 0/0. and this is 0/0 on the service provider side. So what service provider will do that? Service provider will give the dynamically IP to this interface, right? Dynamically IP to this interface. Understand the concept. When the service provider is gonna give the dynamically IP to this interface, you know what happened? So two things he will give. First of all, he will give the IP address. For example, he will give the IP address from the pool of 192.168.1.1. And you know, at the same time, what he will give you, apart from the DNS and those things, right? He will give you one default route. He will give you the one default route as well. And the AD of this default route will be the 254. So it is making sure that, hey, you know one thing, I'm giving the default route, that AD is the 254. If somehow, if this router doesn't have a routes information, then they can use this default route to forward the packet to the internet side. The condition is only what? Your router should be enabled with the IP routing command. And of course, this is the by default enable on the router side. But if you disable it, you will never get the default routing information. Of course, because if you disable the IP routing command, then what happened? You're disabling the routing behavior on the router side. So you will never receive the default route. But normally when the service provider giving the IP address to you, right, you will receive the 0/0/0 route as well, 254. If they allow you, if they not, so they will not. If they are filter this thing, right? So you will not get the default. So my internet service provider is a 192.168.1.254. Okay, that's your IP service provider IP, right? 1.254. For example, my connection, right? So if you see that, I have a RDP, right? So this is my hold on. Hello.
Yeah.
Yeah.
I can hear you.
What I was saying that, so my service, I took the one public IP, right? So the public IP that I took for my server. So this public IP is not given by the DHCP. That I took the static IP address. The reason I took the static IP address because I don't want to change my IP address. Otherwise, what happened whenever my students are gonna access my server, they will use the fixed IP. So if the IP will be keep changing, then what happened? I need to give the I need to give the IP on a daily basis, right? Okay, this IP is changed now, this IP is changed now, this IP is changed now. So it doesn't mean that service provider always give the dynamic IP. It's up to the requirement. You need to tell the service provider, okay, I need a dynamic IP and I need a static IP for that one. So for both things, what happened? The prices are different. Okay, but
okay, I'll let you speak first. I'm sorry, I'll let you speak
so
first.
whenever you give the IP, whenever the service provider give the IP address, they always give the one default route as well as that has an 8254. Again, this default route also they can filter out. But normally when you do the practical, right, on the router 1 and router 2, you can take it and make the router 2 as a DHCP server. And when you put the command IP address DHCP on this particular interface, you will receive a default route. If you manually configure the default route and service provider also provide the default route, then which one will be? Of course, tell me one thing. That's a good question. So when we have a default route with the 0.0.0, that's you manually configure it. The static route. So if you're going to manually configure the static route, the AD value for this guy is a 1. And when the service provider give the default route, with the AD will be what? 254. So obviously this will be preferred. That's you have manually defined it. Understood?
So if you request to the service provider that we need a dynamic IP address, but again, say they keep changing, right? Isn't it? Say as a single customer, if I say, so those IP addresses will be keep changing as you just said. This after 24 hours, are there any,
Yeah, that's a lease
timers?
time, right? 24 hours will be keep changing. That's a lease time. So normally in the lease time, what happens? There's a concept of the timer over the DHCP. So the IP will be not changed, but whenever your router will be boot up, then the IP will be changed over there.
Okay, but once they expire, the new IP address will obviously come automatically, right?
No. So it's not like that. So it's giving the default timer is our lease time is a 24 hours, right? But in a background, these things are totally different. So we have another timer over there, if you see that. So this timer will prevent the IP will be keep changing. what was that? 1 minute. So this is my router one. And it was a DHCP pool that I created, which was what pool name? Do show on section DHCP. And I have a pool name is ABC. And I can see the IP release time as the 0 days. And okay, they haven't defined the name of this guy. Okay, I remember the name. So it's called as our lease time is 24 hours. Then we have a rebinding time, right? And one more time. So this rebinding time, and there's a one more time is there. So this helps me to IP will be keep changing. This prevent the IP will be keep changing at the 24 hours. So there's a timer that's helped me do that. I've explained this thing in the I've explained this timer in one of my video on YouTube, right? Yeah, tell me, go on.
Okay, I will watch your video anyway. So, so basically, let's say I'm a single customer. We have a broadband here, okay, from XYZ company. Okay, so so obviously the IP address has been set up as a dynamically. Okay, so my question is still the same. So no, once we took the like connection from the service provider, okay, so they assigned me the end user IP address as the single customer. So which is 192 whatever. Okay, I mean I can have 190 to 160. I mean,
maximum time will be a public IP address, not the private. So 192 is a private. That's fine. Anyways, not a big deal. Yeah, go ahead.
Okay, so what I'm saying is that so this so next day when I log in again to my system, okay, so the IP address will be same, isn't it? Or it will be changed.
So if you're gonna log out the system, right, then you will have a change IP address. So if your system will be off, I just shown you that, right? So whenever I'm gonna shut down, I'm gonna not shut down the interface. That will keep changing, right? So it's normal behavior.
It's a normal behavior, right?
Okay, it's a normal behavior. But if your system is keep upping, right? Its system is not down, then your IP will not change.
No, it will be keep changing. That means every time when I will turn the machine on, then obviously the the server will be assigned me a new IP address, right?
Yeah, new IP address. Okay, there's a one more way. So sometimes what happens, this is one more good questions comes over there. So what it helps you try to understand. So there is something called as a mapping. DHCP can be assigned the same IP for the same device. What do you mean? Can I assign the same IP for the same device? Okay, I'm coming to the chat question, guys. Just give me 1 more minute. Okay, I got the Kharaj and Nisar question. I just may explain the Nazir guys. Okay, so there is something called as a DHCP MAC IP banding IP.
Okay.
Okay. So normally in that case, what happened? Take example. If I'm going to take example, this is my PC. So this is the PC as the MAC address X, and this is my router server over there, right? So I do have ability. I can do the mapping of this thing. So on the DHCP server, what I can do the mapping X. Always get the IP address 1.1.1. So whenever this PC will turn off, turn on, turn off, turn on, turn on, doesn't matter, right? Always when he will make a request to the router 1, and in this pool I have a bunch of IP address from this range. I have IP address /8, almost 24-bit. I have IP address, right? So whenever this PC will make a request, what happened? I provide the mapping in my database variable, right? So always he will get the IP address from the 1.1. So it doesn't matter how many times it will be on and off. You will always get the 1.1.1.1 IP address through the DHCP. So you can also do like this way. So sometimes the service provider for the one customer, right, can do this thing as well, right? Because
so this is a kind of the feature which we have to request.
This is the features, right? Yeah, this is the features. This is one of the kind of features that we are there in the what we call in the DHCP as well.
Okay, so basically the IP addresses are if we don't, I'm sure they will charge. They may charge for this extra
Of course,
feature.
see, everything is charge or service. Nothing is free, right?
Of course, yeah. When you ask for everything extra, they will, I'm sure. Anyway, a part of that, if you don't ask for this, the IP address will be keep changing. That
Mhm.
means they are not expiring. Just they are the server is generating the new IP address dynamically. It doesn't mean it's expiring, right?
No, doesn't
Because
mean
there's a
so.
timer.
Even your PC goes off and on, right? Whenever he will make a
Yeah.
request, you will get the one only, because I have already provided the back. Can you see that? I see that, hey, the MAC address X, whenever you will get the request from the MAC address X, provide this
No,
IP.
a part of this, a part of this server, sir.
A part of this thing,
Server.
your IP will be changed, right? If your PC will turn on or off.
But that doesn't mean that the IPs are going to be expired. That doesn't mean that,
That
because
doesn't
there's a
mean the
timer
IP is
set.
gonna expire, of course. If you're not gonna make a payment, right, your IP will expire simply.
Obviously, that's a different story.
That's a different, yeah, exactly.
Okay, no worries.
Not
Okay,
done.
because this is very important topic. Every interviews they ask for
So
about the DHCP.
1 minute, let me explain the NASI. 1 minute, hold on. I have a few questions in the group. So VPN hide my IP address, and each time the server change my virtual IP address. See, the VPN that you are using, it's a free VPN, dude. Okay, so yeah, they can hide your IP. That you are thinking that you are hiding the IP address, but normally it's not hiding the IP addresses. That you see, VPN means what? Okay, hold on for this the VPN concept. When I'm going to teach you the VPN, right? In the class, then you will understand the concept of the VPN. Okay. So VPNs are the very different types of the VPN. So when I'm going to teach you, then this question will be clear. Next question can we assign the same IP for the same device? Same IP for the same device. What do you mean by same IP for the same device? You now allocate the one IP as a DHCP and one it's mapping. Got it. Okay, thank you. Now the any other questions you have? No. So let me help you over there. So the thing is that your see your CCNP, right? These are things are there in the DHCP. That's why I have explained this thing. But if you really want to explore the DHCP in a very detailed way, right? Like all the magic cookies, and that the question that the Nasir asked me, right, about the mapping one, I can provide the X.1.1.1 mapping, these things, right? And someone has asked the spoofing one concept, right? So I can help you with the videos, right? 1 minute, let me show you that.